Adhesive Bonding of Polymers and Ultrasonic Welding of Polymers by Ryan Smith and Matt Miller. Today, we will be talking about which of the following processes in which we would like to invest in for our new line of products. We will be covering two of the products that or methods that we suggest: adhesive bonding of polymers and ultrasonic welding of polymers. We will also talk about which of the following that we recommend that we should invest in the new line. Adhesion phenomenon have a specific nature which is caused by the fact that adhesion bonds are formed in the process of interaction between solid surfaces. The solid forces of attraction and repulsion are acting between the atoms and molecules of two approaching surfaces. These forces neutralize each other at equilibrium separation. When the distance between the surfaces, when they are reduced, they will be repulsed from each other. An adhesive bond is formed in two stages. The first stage includes the movement of polymer molecules towards the solid surface and their certain orientation on it. This provides a strong contact between the molecules and functional group of chain molecules of the polymer and counterbody. The second stage of adhesion involves the direct interaction of the polymer and solid surface, which can be caused by different forces from van der Waals to chemicals. Covalent forces become active at a distance between atoms and molecules that does not exceed 0.5 nanometers. Ionic and van der Waals have a broader range of 1 to 10 nanometers.
Ultrasonic welding of polymers. High-frequency local vibrations between workpieces that are forced together. Ultrasonic welding utilizes ultrasonic energy at high frequencies of 20 to 40 kHz to produce low-amplitude mechanical vibrations. The vibrations generate heat at the joint interface of the parts being welded, resulting in melting of the thermoplastic materials and weld formation after cooling. Ultrasonic is the fastest known welding technique, with weld times typically between 0.1 and 1 seconds. Ultrasonic welding also has no foreign substances that are required for ultrasonic welding of specimens. The surface damage is minimal in ultrasonic welding as heat is generated at the interface rather than the top of the surface like in welding processes such as friction welding. It is a clean joining process as it does not generate fumes or sparks during welding and thus is considered environmentally friendly.
We will now compare the two. Both the adhesive bonding of polymers and ultrasonic welding of polymers are both relatively fast processes in order to join materials. They are both economical in different ways. The adhesive bonding of polymers is economical in larger quantities, while ultrasonic welding of polymers is economical in a broader range of quantities, such as low and small. The adhesive bonding of polymers also has more durable welds and is versatile. It is the most versatile joining method. It can be used on complex geometries that other conventional methods, such as ultrasonic welding, is not able to weld. The downside of this is that the solid surface must be heavily prepared, and it can be affected by environmental factors. These factors, like temperature and pressure, affect the final result and the result of the product after it is made. There's a limited temperature range, such as it going too high, the polymer can melt and release the bond. If it goes too low, it can become brittle and the part can break apart. It also has a limited shelf life and could have a lengthy cure time depending on the material. There's also hazardous vapors that could happen between different types of polymers. There is also extensive cleanup depending on how it is manufactured. It is also not able to be disassembled usually unless it is destroyed between the components that form it. While ultrasonic welding of polymers, this is more of a safer, reliable type of process. It is safer because you're able to not have any heat that is generated, and it is more reliable because it is more of a connection bond between other welds because you're not adding anything. It also forms quality joints, and there is reduced material cost because nothing is being added or removed in either the product or the welder. The downside to this is that it isn't ideal for every thermoplastic. It also must have a low moisture level in order to correctly join the two parts together. It can also not produce larger joints. Such joints that exceeds 250 millimeters in length are not able to be welded. It can also only produce lap joints, unlike the adhesive bonding of polymers. It also requires custom tooling and a high initial investment in order to start up the process.
Manufacturing readiness level. Adhesive bonding of polymers. Current level MRL is 10 due to the prevalence of industries that it is used in. Such industries include, but are not limited to, lighting, optical components, sporting goods, office equipment, and etc. The technology is advanced as it could be with the current manufacturing science knowledge, materials science knowledge, and is widely used, accepted, and trusted. Ultrasonic welding of polymers. Current level MRL is 10 as it's a highly utilized process across many industries including computer electronics, automotive, medical, packaging, etc. Since the technology is used in these vast varieties of industries, it is believed to be a 10 on the MRL.
Adhesive bonding of polymers. The adhesive bonding polymers is cost-effective in large batches. However, in smaller batches, it can be relatively expensive. On the other hand, ultrasonic welding of polymers has a very cost-effective in terms of material usage. Ultrasonic welding is highly precise and produces high-quality joints. Part scrapping is kept to a minimal. Low labor costs are kept to a minimal as well due to the low human interaction that is required, though this requires a large initial startup cost.
Recommendation. Due to our company's involvement in a vast number of manufacturing industries with limited specialization, it is our recommendation to start a new line utilizing adhesive bonding of polymers, as adhesive bonding is utilized in many types of joints that help us reach a broader range of products. Due to a large demand, the issue of limited shelf life of the polymers is greatly mitigated as the polymers are utilized at a very fast rate.
For our references, we found all of the information on adhesive bonding of polymers on Science Direct. This is a well-established and trusted publisher with little bias. The ultrasonic welding of polymers was researched using the government websites that have a reduced bias due to their interest in advancing this technology at a realistic rate, while getting rid of any concern with the feasibility of the technology. Thank you.